Hello, in this lecture we'll find out the area of the circle. In the drawing we have quadrilateral ABCD. Inside the quadrilateral we have this circle. Here side AB equals to 2 units in its length. Side BC equals to 8 units in its length. Side DC equals to 8 units in its length. Our mission is to find out the area of this circle. So, first of all, we will do construction. We will extend side DA and side CB until they touch each other. Okay, so and we'll define the touching point between the extended DA and the extended CB as M. We'll define angle DMC, this angle is theta. So we focus on triangle, the big triangle DMC. The big triangle DMC, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta, it is 90 degrees. 90 degrees plus 90 degrees, it is 180 degrees. That is the sum of the angles in any triangle. Actually, we extended the straight line CB by straight line. When we extend the straight line by straight line, the result is a straight line. Therefore, CM is a straight line. So if you focus on the upper side of the straight line CM at point B, which I guess we have here, this angle equals to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles on the upper side of the straight line CM at point B to 180 degrees, the missing angle here must be equal to 180 degrees. The missing angle here, angle ABM, must be equal to 90 degrees. 90 degrees plus 90 degrees, it is 180 degrees. That is the sum of the angles on the upper side of the straight line CM at point B. Okay. So here we focus on triangle A and B. This right triangle A and B. This angle equals to 90 degrees. This angle equals to theta. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Again, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, we'll prove that the big triangle MDC is similar to the small triangle AMB. Okay, so I write it down. The big triangle DCM and the small triangle AMB, they are similar to each other. MAB. So why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So they are equal to each other. So angle DCM in the big triangle, this angle, equals to this angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. Repeat again. Angle TCM in the big triangle equals to angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle theta, it is a common angle that belongs to both triangles. So angle theta equals to itself. Angle theta belongs to the big triangle, and if we relate to angle theta as it belongs to the big triangle, it will be equal to angle DMC. And if we relate to angle theta as it belongs to the small triangle, it will be angle AMB. Now two different names to the same angle theta. Repeat again. So the meaning of this equation is that angle theta equals to itself. Why? Because it is a common angle that belongs to both triangles. Angle theta is angle DMC that is equal to angle theta that is also can define as angle AMB. It is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle MDC in the big triangle equals to angle MAB in the small triangle. Both angles are equal to 90 degrees minus theta, therefore they are equal to each other. Repeat again. Angle MDC equals to, in the big triangle equals to angle MAB in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the angles in the big triangle DCM are correspondingly equal to all the angles of the small triangle A and B. Therefore, the two triangles are similar to each other according to angle similarity rule. So I write it down. The big triangle DCM is similar. This is the sign of similar to the small triangle MAB, according to angle similarity rule. Angle similarity rule is that if you prove that all the angles in one triangle are corresponding equal to all the angles in another triangle, then you prove that actually the two triangles are similar to each other according to angle similarity rule. And from the fact that the two right triangles are similar to each other, we conclude that the following relationship exists between their sides. We conclude that side MC in the big triangle over side MB in the small triangle equals to side DC in the big triangle over side AB in the small triangle. Repeat again. MC over MB equals to DC over AB. Okay, so MC, what is the size of MC? From doing it is very easy to see that MC equals to MB plus BC. Again, MC equals to MB plus BC. So MC over MB equals to DC, DC is 8, over AB is 2. In conclusion, found out that MB plus BC over MB equals to 8 over 2. 8 over 2 is 4. 8 over 2 is 4 and BC equals to 8 units. So MB plus BC, that is 8, over MB equals to 8 over 4. 8 over 2 is 4. Here we'll multiply this equation by MB and we'll get that MB plus 8 equals to 4 times MB. Here we'll subtract MB from this equation and we'll get that here we have 8 equals to 4MB minus MB is 3MB, so 8 equals to 3MB. We divide this equation by 3 and finally we'll get that MB equals to 8 over 3. 8 over 3 units. So here we can write down that side MB equals to 8 over 3 units. In the next step, we'll implement the Pythagoras theorem on the right triangle A and B. And the right small triangle A and B. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendicular. The hypotenuse is AM, therefore the square of the hypotenuse is AM squared. And it must be equal to AB squared plus MB squared. Repeat again. In the right small triangle MAB. Here by PT's version for Pythagoras theorem, AM squared equals to AB squared plus MB squared. So AM squared equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus MB squared. MB is 8 over 3, therefore MB squared is 8 over 3 square. So actually, in conclusion, we found out that AM squared equals to 4 plus 8 over 3 squared. So AM squared equals to 4 plus 8 over 3 squared. It is 8 squared, that is 64, over 3 squared, that is 9. In the next step, we'll take a common factor out of those two expressions. That is to say, we will multiply 4 by 9 and then we will divide it by 9. And we get that AM squared equals to 4 times 9 is 36, and then we divide it by 9. So we multiply it by 9 and we divide it by 9, so we change nothing. So 36, therefore it is allowable. So 36 plus 64 over 9 equals to AM squared. Here AM squared equals to 36 plus 64, it is 100 over 9. Here we'll take a root out of this equation, and finally we'll get that AM equals to the square root of 100 over 9. The square root of 100 is 10, and the square root of 9 is 3. So we found out that AM equals to 10 over 3. Here AM this line segment AM equals to 10 over 3 units. In the next step, I present to you a new rule. Here, side AB is tangent to the circle here, and side BC is tangent to the circle at this point. This point is the center of the circle. We have here rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Tangent AB is tangent to the circle at point M. Point M is the point of tendency, and the radius of the circle is OM. Here it is R, the radius of the circle. So, according to rule number 1, the tangent AB is perpendicular to the radius OM that is drawn to the point of tendency. Here, the radius OM, it is drawn to point M, that is the point of tendency. Therefore, tangent AB will be perpendicular to OM. That is to say, this angle will be equal to 90 degrees, and this angle will be equal to 90 degrees according to this rule, rule number 1. So whenever you have a radius, like in this drawing, that is drawn to the point of tendency, that is to say it is drawn to point M, then the tangent AB will be perpendicular to OM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We can implement rule number 1 in our drawing. So here, we define the center of this circle as O. And here we join here points O and the point of tendency. We define the point of tendency here as M. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius. We define the radius as R. So here we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M. Therefore, tangent AB will be perpendicular to the radius MO. That is to say, this angle equals to 90 degrees, and this angle equals to 90 degrees, according to rule number 1. Likewise, when you find the point of tendency here is point N, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius, that is R. So the radius ON, it is drawn to point N, that is the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay, in the next step, we will draw perpendicular on BC. Again, we will draw perpendicular on BC in such a way that it will be also tangent to the circle. It is absolutely possible. Why? Because when you have the perpendicular here, those two angles are both equal to 90 degrees according to our construction. We define the touching point of the perpendicular in BC as point G. Actually, here it is absolutely possible to draw perpendicular on BC in such a way that it will be also tangent to the circle here. Why? Because the furthest point from the center here, at that point, the perpendicular will be tangent to the circle. Okay, therefore, it is absolutely possible to draw perpendicular that is also tangent to the circle at this point. We define the touching point of the perpendicular from point G to the circle as H. We join points O and N edge together by a straight line. Point O is the center of the circle, point H is the point of the circle itself, therefore OH is the radius of the circle, that is R. Again, we have the radius OH that is drawn to the point of tendency, that is to say it is drawn to point H, that is the point of tendency. Therefore, the tangent GH will be perpendicular to the radius OH. So that is to say, this angle equals to 90 degrees. The other angle will be also equal to 90 degrees. So we focus on quadrilateral MOBN. Inside this quadrilateral, we have 1, 2, 3 right angles. And according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, the missing angle here must be equal to 90 degrees. Why? Because 3 right angles, the sum of 3 right angles, it is 90 times 3, it is 270 degrees. 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. Likewise, we focus on quadrilateral ONQH. In this quadrilateral we have 1, 2, 3 right angles. Therefore, the fourth angle here must be also equal to 90 degrees in order to complete the sum of the angles inside quadrilateral OHNQ to 360 degrees. The missing angle here must be equal to 90 degrees. Okay. So We have here line segment M edge. Line segment M edge, it is a straight line. Why line segment M edge is a straight line? Because this angle in total it is equal to 90 degrees plus 90 degrees. It is 180 degrees. Any angle that is equal to 180 degrees, it is defined as a straight line. And therefore, M edge is a straight line because this angle equals to 180 degrees. So I write it down. Line segment M edge is a straight line because this angle equals to 180 degrees. M edge is a straight line. But again, line segment M edge is a straight line. And because of the fact that line segment M edge is a straight line, M edge is a chord. M edge is a chord. Therefore, M edge is a chord in the circle. M edge is a chord. Is a chord in the circle. But M edge is a chord that passes from point O through the center of the circle. M edge is a chord that passes through the center of the circle. You know that any chord that passes through the center of the circle must be the diameter of the circle. Okay, so M edge is a chord that passes through the center of the circle, and therefore M edge must be the diameter of the circle. Okay, M edge is the diameter of the circle. So M edge, therefore M edge equals to 2R. M edge is the diameter, it is equal to 2R. We will define the radius of the circle not as R but as X. Okay, the radius of the circle is X. And therefore, M edge is the diameter of the circle that is equal to 2x. M edge equals to 2x. In the next step, we'll focus on quadrilateral MBGH, on this big quadrilateral MGGH. Inside this quadrilateral, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we'll relate to quadrilateral MHBG as a rectangle. I write it down. So quadrilateral MHBG that has 4 right angles is a rectangle. Repeat again. Quadrilateral MHBG that has 4 right angles, it is a rectangle. The opposite sides of a rectangle are equal to each other. That is to say, side MH equals to side BG. Okay, side MH equals to side BG. But we have already found out that MH is the diameter of the circle. Okay, MH is the diameter of the circle, and from this equation we derive that BG is also the diameter. So BG is also the diameter, but the diameter of the circle equals to 2x, therefore BG equals to 2x. So we can write down here that BG BG equals to 2x in its length. In the next step, we'll extend the straight line GH until it touches the side MD. And you define the touching point of the extended GH and MD as P. Here, we created here new triangle PM, new right triangle PMG, the big new triangle PMG. Inside the big triangle PMG, we have this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. I repeat again, because why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is 180 degrees. That is the sum of the angles in any triangle. In the next step, we'll prove that the big triangle PMG is similar to the small triangle AMB. Okay, I repeat again. The big triangle PMG is similar to the small triangle AMB. So I write it down. The big triangle PMG is similar to the small triangle AMB. PMG is similar to AMB. Why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So we can write down that angle PGM in the big triangle equals to this angle, that is actually angle ABM, the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. Repeat again. Angle PGM in the big triangle equals to angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle, it is a common angle that belongs to both triangles. So angle theta equals to itself. If we write to angle theta, it belongs to the big triangle, it will be angle PMG. And if we write to angle theta, it belongs to the small triangle, it will be angle B. So I'll repeat again. Actually here we call to angle theta two different names. Angle theta is angle PMG, it is equal to itself. Angle theta can be called also angle A and B. So angle theta is a common angle that belongs to both angles, therefore angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle AMPG in the big triangle equals to angle MAB in the small triangle. Again, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Repeat again. Angle MPG in the big triangle equals to angle MAB in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually we proved that all the three angles in the big triangle PMG are corresponding equal to all the three angles in the small triangle AMB. Therefore, we actually proved that the big triangle PMG is similar. This is the sign of similar to the small triangle AMB. AMB according to angle similarity rule. And from the fact that those two right angles are similar to each other, we conclude that the following relationship exists between their sides. We conclude that MG in the big triangle over MB in the small triangle equals to PG in the big triangle over AB in the small triangle. Repeat again. MG over MB equals to PG over AB. MG equals to 8 over 3 plus 2x. MG equals to MB plus G. MG equals to MB plus BG. And MB plus BG is 8 over 3 plus 2x. Over MB, that is 8 over 3, is equal to PG. PG is the missing side, we leave it as it is, and AB is 2, so we substitute AB by 2. In conclusion, found out actually that over 8 over 3 plus 2x over 8 over 3 equals to PG over 2. Okay. Here we multiply 2x by 3 and then we will divide it by 3. And then we get that 8 over 3, 2x times 3 is 6x. Then we divided 6x by 3, so we change nothing. Divided by 8 over 3 equals to PG over 2. So here We have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And finally we'll get that in this side of the equation we have 8 plus 6x over 8 equals to pg over 2. We'll cross multiply this equation, and finally we get that 2 times 8 plus 6x equals to 8 times pg. We divide this equation by 2, and we get that 8 plus 6x equals to 8 over 2 is 4 pg. Here we'll divide this equation by 4, and finally we get that pg equals to 8 over 2, 8 over 4 is 2, 6 over 4 is 1.5. So it is 2 plus 1.5x. We actually found out that line segment PG, this line segment PG, it is equal to 2 plus 1.5x. We will continue to focus on the same right triangles that are similar to each other from the fact that those two right triangles are similar to each other. We'll conclude that we have another relationship between the sides of the two triangles. We get that MG in the big triangle over MB in the small triangle equals to MP in the big triangle over MA in the small triangle. Okay, repeat again. From the fact that this triangle is similar to the big triangle, we conclude that the following relationship exists between their sides. That MG over MB equals to MP over MA. MG is 8 over 3 plus 2x. Over MB is 8 over 3 equals to MP. MP equals to MA plus AP. Again, MP equals to MA plus AP. That is to say, it is equal to MA, that is 8 over 3 plus AP. AP is the missing variable. Over MA is 10 over 3. Repeat again. So we got this equation. Here we'll multiply 2x by 3 and then we'll divide it by 3. And here also we'll multiply AP by 3 and then we'll divide it by 3 in order to have a common factor of this expression. So we have 8 over 3 plus 2x times 3 is 6x divided by 3. Over 8 over 3 equals to, again, we have 10 plus 3 times AP over 3 divided by 8 over 3. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. Here also we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And finally we get that this side of the equation we have 8 plus 6x over 8 equals to 8 over 3 AP over 8. Okay. This is the expression after we cancelled 3 on both sides of the equation. Here we cross multiply this equation and finally we get that 10 times 8 plus 6x equals to 8 times 10 plus 3AP. Here we open the brackets on both sides of the equation. 10 times 8 is 80, plus 10 times 6x it is 60x, plus 8 times 10 it is 80, plus 8 times 3 AP it is 24 AP. We have 80 on both sides of the equation, so 80 will get cancelled, and finally we get that 24 AP equals to 60. Here we'll divide this equation by 24, and finally we get that AP equals to 60 over 24. It is it's actually 60x. So we divided this equation by 60x. We divided this equation by 24, so it is 60x over 24. So just copy 60x here. So we divide this equation by 24 and we get that 60x over 24 is 2.5x. Finally we found out that line segment AP equals to 2.5x. This line segment AP equals to 2.5x in its size. In the next step, I'll copy the quadrangle APGB in the new page and we analyze this quadrangle. So actually, this is quadrangle APBG that I copied from the original drawing. Quadrangle APBG. This quadrangle blocks a circle. This is the circle that quadrangle APBG blocks. So I copied that circle that is blocked by the quadrangle. Okay. We have here 4 points of tendency between the quadrangle APBG and the circle. We define the first point of tendency here as L. We define the second point of tendency as M. We define the third point of tendency as N. And we define the fourth point of tendency between the circle and the quadrilateral LPBG is O. Okay. We have here, we can implement here rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Point P is the common external point in relation to this circle. From point P we have two tangents to this circle, tangent PA and tangent PB. And according to rule number 2, whenever you draw from a common external point, that is to say from point P, two tangents to the circle, their lengths will be equal. That is to say the length of the first tangent PA is equal to PB. Here we can implement the new rule number 2 in our drawing. If we relate to point A, so from point A we have two tangents to this circle, tangent AL and tangent AM. And according to rule number 2, tangent AL equals to tangent MA. Okay, because the two tangents exist from the common external point A, therefore they must be equal to each other. So if AL equals to A, then AM must be also equal to A. So likewise, we will relate to point B, to the common external point B, here. From the common external point B, we have two tangents to the circle, tangent BN and tangent BM. And according to rule number 2, tangent BM must be equal to tangent BN. So if BM equals to B, then BN must be also equal to B because they are equal to each other according to rule number 2. Likewise, we will relate to the common external point G. From the common external point G, we have two tangents to this circle, tangent GN and tangent GO. And GN must be equal to GO according to rule number 2. So if GN is C, then OG must be also equal to C because they are equal to each other according to rule number 2. So here, those two line segments are equal to C each other. And finally, we relate to the common external point P. From the common external point P, we have two tangents to this circle, tangent PL and tangent PO, and according to rule number 2, PL equals to PO. So if PL is D, then PO must be also equal to D. Okay. Now we will add side AP and side BG of this quadrilateral APBG with each other. So here AP plus BG, side AP plus side BG. What is the length of side AP? Side AP, according to this drawing, is already to see that AP equals to A plus D plus BG. What is the length of BG? From this drawing, it is already to see that BG equals to B plus C. So in conclusion, we found out that in quadrilateral APBG, AP plus BG equals to A plus D plus B plus C. In the next step, we will add side AB to side PG. And repeat again, we'll add side AB to side PG. So AB plus PG. What is the length of side AB? Side AB equals to A plus B plus PG. PG, it is D plus C. So in conclusion, we found out that AB plus PG equals to A plus B plus D plus C. Again, A plus B plus D plus C. But AP plus BG also equals to A plus D plus B plus C. Here we have A here, B, D, and C. That is to say, according to the equation, those two, AP plus BG equals to AB plus PG. Why? Because both sides are equal to A plus B plus C plus D, therefore they are equal to each other. So write it down, side AP plus side BG equals to side AB plus side PG. So here, now what is the length of AP? AP equals to 2.5x. So you can substitute AP by 2.5x plus BG. What is the length of BG? From the drawing, you can see here that BG equals to 2x. BG equals to 2x, so you can substitute BG by 2x here. And it is equal to AB. AB, it is given us the equation that AB equals to 2, so we'll substitute AB by 2 plus PG. PG, we already found out that PG equals to 2 plus 1.5x. So we substitute PG in this equation by 2 plus 1.5x. So on this side of the equation we have 2.5x plus 2x, it is 4.5x, and it is equal to 2 plus 2 is 4 plus 1.5x. We subtract 1.5x from this equation, and finally we get that 4.5x minus 1.5x, it is 3x, that is equal to 4. Here we divide this equation by 3, and finally we get that x equals to 4 over 3. That is to say, the radius of this circle equals to 4 over 3 units. We know that the area of any circle, here the square brackets is the sign for the area. That means that the area of a circle in general is equal to pi times the radius squared. So pi times the r. R is, here r, the radius of the circle is 4 over 3. 4 over 3 squared. That is the area of our circle. So it is pi, 4 square is 16, over 3 square is 9. In terms of numbers, so it is 16 pi over 9 square units. In terms of numbers, it is equal to 5.585 square units. And that is the answer to our question. The area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equal to 5.585 units. It is about 5.6 square units. In the next step, I will summarize the lecture. this lecture we found out the area of this circle. This circle is actually inside quadrilateral ABGP. It is actually inside quadrilateral ABCD. Again, this circle is located inside quadrilateral ABCD. The length of side AB is 2 units, side BC equals to 8 units in length, side DC equals to also 8 units in length. Angle DCV equals to 90 degrees in its length, and its size. And this angle ABC equals to also 90 degrees in its size. Again, our mission is to find out the area of this circle. In the first step, we extended side D8 and side CB of quadrilateral ABCD until they touch each other. We define the touching point of the two extended sides, DA and CB as M. We define this angle as theta. Here, CB is a straight line. When you extend a straight line by straight line, the result is a straight line. So CM is also a straight line. So if you focus on the upper side of the straight line CB, of the straight line CM at point B, which angles we have on the upper side of CB at point B? We have this angle that is 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of CB at point B to 180 degrees, the missing angle here must be equal to 90 degrees. So angle ABM equals to 90 degrees in its size. So we define this angle as theta, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta, it is 90 degrees. And 90 degrees plus 90 degrees, it is 180 degrees. That is the sum of the angles in any triangle. Likewise, if you focus on the big triangle, the big rectangle MDC, this angle equals to 90 degrees, this angle equals to theta, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we proved that the big triangle MDC, the big right triangle MDC, is similar to the right triangle AMB. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle theta, is a common angle that belongs to both triangles, therefore angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So if we proved that all the three angles in the big right triangle MCD are correspondingly similar to all the angles in the small triangle AMB. Therefore, those two triangles are similar to each other according to angle similarity rule. And from the fact that those two triangles are similar to each other, we get that the following relationship exists between their sides. That MC, the big triangle, over MB, the small triangle, equals to DC in the big triangle over AB in the small triangle. I repeat again. MC over MB equals to DC over AB. MC equals to MB plus BC. Okay. So here MC equals to MB plus BC over MB equals to DC is 8 and AB is 2. So MB plus BC is 8 over MB equals to 8 over 2 is 4. Here we multiply this equation by MB, and regard that MB plus 8 equals to 4MB. We subtracted MB from this equation, and finally we found out that 8 equals to 4MB minus 1MB, it is 3MB. We divided this equation by 3, and finally we found out that MB equals to 8 over 3 units. Here, this side MB equals to 8 over 3 units. Then we implemented the Pythagoras theorem on this right triangle ABM. According to the Pythagoras theorem, AM squared equals to AB squared plus MB squared. Repeat again. In the right triangle AMB, according to the Pythagoras theorem, AM squared equals to AB squared plus MB squared. So AM squared equals to AB squared. It is AB squared. AB is 2, therefore MB squared is 2 squared, that is 4, plus MB squared. MB is 8 over 3, therefore MB squared is 8 over 3 squared. So we found out that AM squared equals to 4 plus 8 over 3 squared. 8 over 3 squared, it is 8 squared, that is 64, over 3 squared, that is 9. So AM squared equals to 4 plus 64 over 9. Here we took a common factor of those two expressions, that is to say we multiplied 4 by 9 and then we divided by 9. 4 times 9 is 36, so it is 36 plus 69, and then we divided by 9. So AM squared equals to 36 plus 64 over 9. 36 plus 64, it is 100 over 9. So AM squared equals to 100 over 9. We took a root of this equation and finally found out that AM equals to the square root of 100 over 9. The square root of 100 is 10, and the square root of 9 is 3. So in conclusion, we found out that AM equals to 10 over 3 units. AM, or MA, equals to 10 over 3 units. Okay, then I presented to you a new rule, and we implemented a new rule in our drawing. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So the radius of the circle is OM, it is equal to R, and AB is tangent to this circle at point M. That is to say, point M is the point of tangency. Here we have the radius OM that is drawn to the point of tangency, that is to say, it is drawn to point M. And then whenever we have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to MO. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule, rule number 1. So we can implement rule number 1 in our drawing. Why? Because in our drawing we have here AB is tangent to the circle at point M. We join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that we defined as X. So the radius OM is drawn to point M, that is the point of tendency, therefore according to rule number 1, tangent AB will be perpendicular to MO, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. Likewise, we have BG is tangent to this circle at point N. Point N is the point of tendency. Point O is the center of the circle. Point N is the point of the circle itself. Therefore, ON is the radius. So the radius ON, it is drawn to the point of tendency. That is to say, it is drawn to point N. That is the point of tendency. Therefore, tangent BG will be perpendicular to the radius NO. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule number 1. So here, in quadrilateral MBNO, we have 1, 2, 3 right angles, and according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So we have 3 angles that is equal in total to 270 degrees plus the missing angle. The missing angle must be equal to 90 degrees. In order to complete the sum of the angles in quadrilateral MOBN to 360 degrees, the missing angle here must be equal to 90 degrees. In the next step, we draw perpendicular on BC in such a way that the perpendicular that we constructed here will be also tangent to the circle at point H. It is absolutely possible to do it. Actually, in the farthest point of the circle from the center, the perpendicular will be tangent to this circle exactly the farthest point of the circle from point O. Okay? Therefore, it is absolutely possible to do it. So here, so this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So here PG is a tangent to the circle at point H. We join points O and H together by straight line. Point O is the center of the circle, point H is the point of the circle itself, therefore OH is the radius of the circle that we defined as X. So the radius OH, it is drawn to the point of tendency, that is to say it is drawn to point H, that is the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees, the tangent PG will be perpendicular to the radius HO. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees, according to rule number 1. So in quadrilateral OHGN, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And here, line segment MH is a straight line. Why? Because this angle edge OM equals to 180 degrees. Any angle that is equal to 180 degrees, it is a straight line. Therefore, MH, line segment MH must be a straight line. Okay, I'll repeat again. MH is a straight line. And because the straight line touch the circle at 2 points M and H, line segment MH is a chord. Again, line segment MH is a chord because it touches the circle at those 2 points M and H. Okay? And chord MH passes through the center of the circle, that is to say it passes through point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle, and therefore MH is the diameter of the circle. Okay? MH must be the diameter of the circle because it passes through the center of the circle. It is a chord that passes through the center of the circle, therefore it is the diameter of the circle. So MH is the diameter of the circle, that is equal to, therefore it is equal to 2x. Okay? MH equals to 2x. Then we actually focused on quadrilateral MH BQ. Again, MH is a straight line. Okay? MH is a straight line, therefore MH BQ is a quadrilateral. Okay? Inside quadrilateral MH GB, we have 1, 2, 3 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square, so we relate to quadrilateral MBGH as a rectangle. And we know that the opposite sides of a rectangle are equal to each other, that is to say MH equals to BG. MH equals to BG. So you can write here that MH equals to BG. but we have already found out that m edge is the diameter of the circle. Yeah, m edge is the diameter of the circle. And from this equation, bg equals to m edge equals to the diameter, we derive that bg is also the diameter. Okay, bg is also the diameter. If bg is the diameter, it means that it is equals to 2 times the radius, that is to say, and the radius is x, therefore bg equals to 2x. Here, line segment bg equals to 2x in its length. In the next step, we extended the tangent g edge until it touches the circle at point P. Point P is the touching point of the extended g edge and side MD. So we created the triangle MPG, the right triangle MPG. We proved that the right triangle MPG is similar to the small triangle MAB. So the big triangle MPG is similar to the small triangle MAB. Why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle equals to theta. It is a common angle that belongs to both triangles, therefore angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. Now, shall we prove that all the angles in the big triangle MTG are correspondingly similar to all the angles of triangle MAB. Therefore, those two triangles are similar to each other according to angle similarity rule. Okay, triangle PMG is similar to triangle AMB according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will derive that the following relationship exists between their sides. That MG in the big triangle over MB in the small triangle equals to PG in the big triangle over AB in the small triangle. I'll repeat again. MG over MB equals to PG over AB. MG equals to MB plus BG. Again, MG equals to MB plus BG. MG is 8 over 3 and BG is 2x. So we substitute MG by 8 over 3 plus 2x over MB is 8 over 3. MB is 8 over 3. Over PG is unknown, so we leave it as it is. Over AB. AB is 2. So we substitute AB by 2. Then we multiply 2x by 3 and then we divide it by 3 in order to have a common factor of 8 over 3. So here we have 8. 2x times 3 is 6x, so it is 6 over 3 equals to over 8 over 3 equals to PG over 2. We have 3 in the numerator, 3 in the denominator, therefore 3 will get cancelled. And finally found out that 8 over 6x over 8, 8 over 6x over 8 equals to PG over 2. Because multiply this equation, and finally found out that 2 times 8 plus 6x equals to 8 times PG. Here we divided this equation by 2, and we got that 8 plus 6x equals to 8 over 2 is 4. So 8 plus 6x equals to 4 times PG. We divided this equation by 4 and finally found out that PG equals to 8 over 4 is 2 and 6 over 4 is 1.5x. So we found out that PG equals to 2 plus 1.5x. Here this line segment PG equals to 2 plus 1.5x. From the fact that the big triangle MPG is similar to the small triangle MAB, we get that the following relationship exists between their sides. That MG in the big triangle over MB in the small triangle equals to MP in the big triangle over MA in the small triangle. I'll repeat again. MG over MB equals to MP over AM. Again, MG equals to MB plus BG, that is 8 over 3 plus 2x. So substitute mg by 8 over 3 plus 2x. mb is 8 over 3 over mp. mp equals to ma plus ap. ma equals to 8 over 3 and ap is unknown. So we substitute mp by 8 over 3 plus ap. We substitute mp by 8 over 3 plus ap. Over ma it is 8 over 3. So here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. So it is 8 plus 2x times 3 is 6x divided by 3 over 8 over 3. Again here we also multiply the AP by 3 and then we divide it by 3 in order to have a common factor of 8 over 3. So 8 plus AP plus AP times 3 is 3AP over 3 over 8 over 3. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. Here also we have 3 in the numerator and 3 in the denominator, so here 3 also get cancelled. And finally we found out that 8 plus 6x over 8 equals to 10 plus 3AP over 10. Here we cross multiply this equation and we found out that 10 times 8 plus 6x equals to 8 times 10 plus 3AP. Here we open the brackets on both sides of the equation and found out that 10 times 8 is 80 plus 8 times 6x is 60x equals to 8 times 10 is 80 plus 8 times 3AP is 24AP. So we have 80 in the both sides of the equation, so 80 will get cancelled, and finally we found out that 60x equals to 24AP. We divided this equation by 24 and finally found out that AP equals to 60x over 24, which is 2.5x. Here, this line segment AP equals to 2.5x in its size. Then I copied quadrilateral APGB in the new page and we analyze it. So this is quadrilateral APBG that I copied from the original drawing. Inside this quadrilateral APBG we have a circle that is blocked by the quadrilateral. This circle is blocked by quadrilateral APBG. Therefore I copied the circle here. So here the circle touches the quadrilateral in 4 points. That is to say, we have 4 points of tangencies between the circle and the quadrilateral. We define the first point of tangency as L. We define the second point of tangency between the quadrilateral and the circle as M. We define the third point of tangency between the circle and the quadrilateral as N. And finally we define the fourth point of tangency between the circle and the quadrilateral as O. And then I presented to you rule number 2, and we implemented rule number 2 in our drawing. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So point B is a common external point in relation to this circle. From point P we draw two tangents to this circle. The first tangent is PA and the second tangent is PP. According to rule number 2, the lengths of two tangents of those two tangents are equal to each other. That is to say PA equals to PB. We can implement rule number 2 in our drawing. Why? Because in our drawing we have the common external point, point A. From the common external point, point A, we have two tangents to this circle, tangent AM and tangent AN. And according to rule number 2, they are equal to each other. That is to say AL equals to MA. So if AL is A, then AM must be also equal to A. Then we have the common external point, point B. From the common external point, point B, we have two tangents to this circle, tangent BN and tangent BM. And according to rule number 2, they are equal to each other. That is to say BM equals to BN. So if BM is B, then BN must be also B. Then we have the third tangent to this circle, Actually, we have point G, that is the common external point in relation to this circle. From point G, we have, from the common external point G, we have two tangents to this circle, tangent DN and tangent DO. And according to rule number 2, GN equals to GO. GN equals to GO. So if GN is C, then GO must be also equal to C. And finally, we have the fourth external point, point P. From the fourth external point, for the fourth common external point, point P, we have two tangents to this circle. Tangent PL and tangent PO, and according to rule number 2, PL equals to PO. So if PL is D, then PO must be also equal to D. PL equals to PO equals to D. Okay, in the next step, we added point side AP to side BG. Okay, yeah. Side AP plus side BG. AP equals to A plus D. AP equals to A plus D. AP equals to A plus D plus BG. BG equals to B plus C. BG equals to B plus C. Also BG equals to B plus C. So actually found out that AP plus BG equals to A plus D plus B plus C. This is actually A plus B plus C plus D. And then we added AB and PG. AB plus PG. Okay. AB plus PG. AB equals to A plus B and PG equals to C plus D. Therefore, AB plus PG in total equals to A plus B plus C plus D. Actually, both AP plus BG and AP plus BG, they are both equal to A plus B plus C plus D. And therefore, they must be equal to each other, of course. So AP plus BG equals to AB plus BG. AP what is the length of AP? We already found out that AP equals to 2.5x in its length. So we substitute AP by 2.5x. What is the length of BG? Here, we already found out that BG equals to 2x in its length. So we substitute BG by 2x, and it is equal to AB. AB equals to 2 units according to what is given as the equation, and PG, we have already found out that PG equals to 2 plus 1.5x, so we substitute PG by 2 plus 1.5x. So actually found out that 2.5x plus 2x equals to 2 plus 1.5x. 2.5x plus 2 is 4.5x, and it is equal to 2 plus 2 is 4 plus 1.5x. Here we subtracted 1.5x from this equation and found out that 4.5x minus 1.5x equals to 3x. So if 3x equals to 4, we divided this equation by 3. And finally found out that x, the radius of the circle, equals to 4 over 3 units. And the area of any circle equals to pi times the radius squared. That is to say it is pi r squared if r is the radius. R, the radius of the circle, according to our definition, the radius of this circle equals to x. And therefore, the area of the circle will be equal to pi times x squared, that is pi, and x equals to 4 over 3, so the area of the circle equals to pi times 4 over 3 squared, that is to say it is pi times 4 squared is 16 over 3 squared is 9. So in conclusion, we found out that the area of this circle equals to 16 pi over 9 square units, or in terms of numbers, it is equal to 5.585 square units. Okay, thank you very much.